Set photography support. In this section, he discusses the probable method of construction of the stage set. He says that the stage sets were first created using wooden structures to define the main contours of the ground. Then, the sticky sand was sprayed upon the top layers, darker sand first, then topped with lighter colored sand, possibly built up in several layers. Finally, rocks were creatively arranged on the top of the sand. And then, more sand of both light and dark colors were sprayed over to complete that essential moon look. The result was quite realistic, especially as no one had ever been to the moon, so had no appreciation of how it should look. He then examines the panoramas that constitute what he says are the projected image background. The detail for these panoramas was from the lunar satellite photography. It did not need to be perfect, but had to resemble the area where the astronauts allegedly landed. He shows many of the panoramic scenes used on the circular stage. He mentions the quite obvious interface between the physical set and the projected image. In most Apollo videos, this line is very apparent and has been commented on by many skeptics, but seemingly ignored by the pro-NASA crowd. It has also become known as the Kubrick horizontal, as it mimics the technique used by Stanley Kubrick in the movie 2001: A Space Odyssey. In the later part of the video, he discusses stereoscopic images, and where the photographs overlap, it shows the interface line more clearly. The use of these overlapped images to judge the distance to supposedly distant mountains is described in this paper from Oleg Olenik on the Alice.com website. Lunar Rover Vehicle Rig. Quite sophisticated simulators, sophisticated at least for the 1960s, were built extensively to train the astronauts before the alleged moon landings. It is quite possible that these same simulators were also employed to create the hoax moon landing that we see in the Apollo footage. It is also quite possible that other large simulators were also developed by NASA as part of the astronaut training program, but were never disclosed. He also suggests that NASA had at their disposal several types of stop-motion techniques, including motion control cameras. He goes on to propose that NASA had some special virtual reality techniques which were perhaps ahead of their time. We know that John Dykstra had achieved some convincing virtual reality effects using small-scale models. In the moon footage, the lunar rover vehicle was alleged to have traversed quite large distances, up to 27 kilometers according to NASA. This range of travel was much further than any set that could be reasonably constructed. He provides a suggestion of how this apparent distant range was achieved using a lunar rover simulator, which consisted of a camera on a movable boom that could be guided over a detailed model of the moonscape. They may have had life-sized lunar rovers in front of the camera on which the astronauts could be seated, so providing the illusion that they were traversing the ground. He makes an interesting point. The simulators used to train the astronauts could have been purposely made cruder than what NASA had available. This misrepresentation would be in order not to reveal the more sophisticated techniques that they had developed and that were later used to create the actual hoax. He then shows what he believes to have been the setup used, probably using a snorkel lens filming at a slower frame rate. He even suggests that the lunar rover vehicle used was a model which had also been alluded to by several skeptics. He shows some examples from the early 1970s of the work by John Dykstra to illustrate what may have been possible. These examples used tiny models with a snorkel camera to achieve extraordinary realistic virtual reality. The technique of motion control on these tiny sets was probably first pioneered by NASA X. We now see it being used extensively in virtual reality today. He also shows that the Lunar Orbiter and Landing Approach Simulator, LOLA, which NASA used to train the astronauts for the supposed moon landing. The videos produced with this setup are much less believable than what we see in the actual lunar landing footage, but this may have been part of the ploy. Finally, he demonstrates a simulator that he generated as a computer model to show how easy it would be to produce realistic footage of the lunar rover, providing the terrain is detailed and accurate. But back in the 1960s, this was at a very cutting edge of what was actually achievable. We are no longer amazed or impressed by the computer-generated imagery or special effects, but back in the 1960s, this was at the very cutting edge of what was then achievable. Lunar rover vehicle footage. In this next section, the narrator examines some of the lunar rover footage. He remains inconclusive on how they faked the footage, whether it was generated only from a model or done on some stage set, or more probably, a combination of the two. The supposition that the lunar rover may have been a model has been something that had been claimed by several skeptics. One reason for this is that the astronaut supposedly driving the lunar rover has his left arm stuck out and immobile throughout the complete Grand Prix video sequence. Landing sequences. The narrator takes a detailed look at the Apollo lunar landing footage. He notes that several mistakes were made with the VFX trickery that is very revealing. He maintains that the initial landing sequence was filmed by a camera hovering over a model of the lunar landscape. As the supposed spacecraft was about to land, a mat was used to represent sand blown across the view. This fake sand sequence provided the cover for the simulation to dissolve into the view of the actual full-sized stage set. The lunar landscape model sometimes shows some visible telltale boundary strips which reveal how the model was made using plaster or some other material. This fake sand sequence provided the cover for the simulation to dissolve into the view of the actual full-sized stage set. The lunar landscape model sometimes shows this visible telltale boundary strip which reveals how the model was made using plaster or some other material. It was constructed by copying the detailed image strips produced by the lunar orbiter. These boundary strips are often hard to detect but do exist in places. He illustrates his point by using the Apollo 14 landing sequence, and by increasing the contrast of the video, the faint boundary strips are revealed. In the Apollo 14 footage, he shows that the dissolve from model to full-size stage set was not entirely convincing, as the blown sand mat did not completely obscure the image. He states that the giveaway is in the crater shadows as they change slightly between the two versions from the model to the full-size stage set. He thinks that this error is revealing evidence for the fakery, as it proved very difficult to match up convincingly the detail between the model and the full-sized set. He notes that in all other landing sequence footages, the blown dust completely hides the image at the dissolving point, and a comparison of the two images cannot be analyzed. He also identifies a further anomaly in Apollo 14. Some object at the top right of the window changes shape during the dissolve. It is initially a round shape on the model, but changes to a square in the physical stage set. Who? The narrator says that Douglas Trumbull was the likely mastermind behind the visual effects work of the Apollo fakery. Trumbull worked on Cinerama and the movie 2001: A Space Odyssey before the Apollo visual effects project. As a result, he had considerable experience of moon simulation, and NASA X likely approached him when they realized they decided to fake the moon landings. He also suggests that there is evidence, although he does not state any source for this assertion, that NASA X was involved in the movie 2001: A Space Odyssey as a means of identifying if the visual effects technology was suitable for this Apollo simulation. What is certain is that Trumbull did possess most of the skills required by NASA X to accomplish the moon fakery. He shows a presentation by Douglas Trumbull in which Trumbull describes how they built miniature IMAX cameras small enough to be used inside of models for the movie Back to the Future. He mentions how they had used microscopically thin monofilament wire that was not supposed to be captured by the camera. He continues to suggest who was behind the hoax and who knew what was truly going on. He believes that not many people were in the know. He also thinks that only a few people in Mission Control knew of the hoax, and everyone else was fooled along with us. The technicians were doing all their usual individual allocated jobs of monitoring their designated data outputs. They would be oblivious to the fact that what they were watching was a simulation. He suggests that there were probably a few CIA agents in Mission Control. The only people allowed to talk to the on-the-moon astronauts were the other astronauts, and all of the astronauts must have been in the know. Naturally, all of the camera crew involved in the filming must have been in the know, but these were very likely DIA-CIA agents. One person who must have been in the know to ensure the correct operation of the hoax was the camera operator in Mission Control. Whether he needed to perform any task is unclear. Perhaps he was just there to fill the chair and look busy. Finally, he suspects that NASA X is actually an intel operation as a front for the CIA, perhaps from its inception, or was subsequently infiltrated by the CIA. He goes as far as to say that he believes that the entire USA space program is a front and that the real reason for its existence is to put spy satellites up to control the world. Well, that may be another story. In the video, the narrator mentions the NASA simulators. These simulators are crucial to our story as they provide some of the most compelling evidence that all of the alleged live TV footage by NASA was faked. NASA Apollo simulators. We understand the simulators very well in our modern world. Everything from aircraft, cars, trucks, boats, and many other complex systems make use of them to train the drivers or operators. A simulator is a purpose-designed environment which provides a realistic imitation of the controls and operation of the systems, be it a vehicle, aircraft, or any other machine. Simulators are useful as an inexpensive way to train many people for what could otherwise lead to high-risk and costly accidents in the real world. Improper use only results in software-controlled errors and with no dangerous outcome except perhaps to the trainee's pride. Back in the 1960s, simulators were quite simple systems as there was not then the advanced computer technology that we use today. Nevertheless, NASA created 15 simulators ostensibly to train the astronauts. Several of these simulators had cross-functionality. This paper, Computers in Spaceflight, the NASA Experience, produced by NASA, states, no less than 15 simulators trained crews during the Apollo program. 3 were on the primary command module simulators, with 1 at Houston and a pair at the Cape. 2 were the primary lunar module simulators, 1 at each site. At Houston, a command module procedures simulator trained crews just to rendezvous with the command module, as there was a lunar module procedures simulator for landing module, rendezvous, and landing training. Gemini's dynamic crew procedure simulator became the same for Apollo. Additional moving base simulators at the Manned Space Flight Center were for lunar module formation flying and a centrifuge to avoid trips to Johnsonville. Langley Space Flight Center pioneered the research into the final 200 feet of lunar landing by suspending 5/6 of the simulator's weight to give the astronauts practice in controlling the lander in the gravity of the moon. Another lunar landing simulator used a jet engine to support 5/6 of its weight and permit free flight landing training. That simulator required a simulator of its own to keep the crews from crashing it. Finally, a pair of partial gravity simulators gave the astronauts the chance to walk in spacesuits while having 5/6 of their weight supported. Later in the program, Marshall Space Flight Center built a simulator for the lunar rover vehicle. Among the plethora of simulators, use of the command module simulators and lunar module simulators nonetheless occupied 80% of the Apollo training time of 26,967 hours. These simulators and their associated computer systems were crucial to the success of the program. The Apollo 13 emergency in April 1970, when there was an explosion in the service module on the way to the moon, demonstrated the high fidelity and flexibility of the simulators. As all lunar module engines burn, separations and maneuvers could be tested, and as a Hawk procedure developed as the crippled mission progressed. In contrast to the procedure simulators, all of which were driven by a single mainframe computer, the mission simulators used networks of several computers. Honeywell won a $4.2 million contract on July 21, 1966, to supply DDP-224 computers for the complexes. Singerlink was again the contractor for the simulators. Singer allocated 3 computers for the command module mission simulators and 2 for the lunar module simulators. The sets of computers could communicate among themselves by using 8K words of common memory, where information needed throughout the simulation could be stored. Later, a 3rd and 4th computer were added, respectively, to the lunar and command module simulators. These computers simulated the onboard computers. By the Apollo 10 flight, a 5th computer, simulating the launch vehicle, completed the command module simulator's computer complex. The two types of simulators and the Mission Control Center could do integrated simulations, thus requiring up to 10 digital computers to be working on one large problem simultaneously. This previous sentence is relevant. These simulators and their associated computer systems were crucial to the success of the program. These simulators were also crucial, in fact essential, for NASA X to create the fake footage of docking, undocking maneuvers, lunar landings, and lunar orbits. The realism aspect of the simulators was important, and judging by what the Apollo flight director Gene Kranz emphasized in his book, Failure is Not an Option, published 23 June 2009, it was successful enough to deceive everyone, including the operatives in mission control. It states, "The simulators were some of the most complex technology in the entire space program. The only real things in the simulation training were the crew, cockpit, and the mission control consoles. Everything else was make-believe created in a bunch of computers, lots of formulas, and skilled technicians." In the late 1960s, our simulation technology had progressed to the point where it became virtually impossible to separate the training from the actual missions. The simulations became full dress rehearsals for the missions right down to the smallest detail. The simulation tested out the crew's and controllers' responses to normal and emergency conditions. It checked out the exact flight plan, mission rules, and procedures that the crew and controllers would use for a later flight. The simulations were so real that no controller could discern the difference between the training and the real mission. The NASA Apollo mission simulators are described in this video from the 1960s. The scale of the NASA Manned Spacecraft Center in Houston, Texas is quite impressive. It comprised over 100 buildings covering an area of 1,600 acres or 650 hectares. In the center, all of the astronauts were recruited and trained on the many simulators. Computer technology had progressed enormously since then. Just imagine that the power of the plethora of computers that you see in this video are for a less computational power than the smartphone in your pocket or handbag. The Apollo mission simulator had the appearance of a pile of cardboard boxes after the Christmas present unwrapping, 65 feet wide, 30 feet high, and over 100 feet long, weighing an incredible 40 tons. The pro-NASA devotees have long argued that it would be easier to go to the moon than fake it going to the moon. They contend that faking it in the 1960s would have been impossible. My response to this would be, if they could fool the NASA mission control operatives who believed they were controlling the mission into believing that it was real, then I think that it would be pure arrogance to assume that they could not also fool the rest of us. We will now examine some of the simulators that were ostensibly designed to train the astronauts and, perhaps more significantly, enable NASA X to pull off the hoax so successfully. Apollo Mission Simulator. This simulator was a computer-controlled system designed to provide the astronauts with realistic experiences of operating the command module. It was a derivation of similar simulators used for the Mercury and Gemini programs. It incorporated simulated out-of-the-window scenes projected from the outside onto the cabin windows. This system provided the astronauts with a certain amount of realism. The simulator could also display star patterns and lunar orbital landing scenery. The report goes on to state, repeated simulation exposure allows the crew to become proficient in interfacing with the flight hardware and ground support elements, thus enhancing mission success and safety. In this context, a simulator is designed as a complex set of hardware, including computers, visual display systems, and simulated crew stations, that presents, with a high degree of accuracy, the total flight characteristics of the actual spacecraft and mission. The one interesting comment in this report identifies the realism required for the visual system of the lunar landing was not being met by the existing system. Another area that required considerable updating and redesign was the difficult visual simulation of the lunar landing. As will be discussed in the section on visual display simulation, the initial concept of the LMS fell short of the realism required. An intensive development effort was undertaken to improve the visual simulation of the lunar landing and, at the same time, to permit timely use of the LMS for the early orbital training. This effort was successfully concluded to provide high-fidelity landing and ascent training for the first lunar landing and subsequent flights. At the time, this visual display technology was pioneering work for NASA. The window displays needed to be as realistic as possible. This realism was essential for the astronauts to correlate to the view that they see on the outside terrain with that seen on the instrument settings on the control panel. This realism was equally crucial to convince the world that it was real. It was the output from these realistic lunar landing simulators that created all of the alleged real Apollo moon landing footage. Command Module Simulator. The Command Module Simulator was an integral part of the Apollo mission simulator. This silent NASA video from the 1960s provides an overview of the system. The video text reads, "Simulations are an integral part of preparing the crews and ground teams for conducting safe flight operations in space. The crew reacts to the errors and anomalies the ground crews put in the simulation, and the ground crew analyzes the crew's performance and readiness." The Command Module Simulator was used at Kennedy Space Center and at the Johnson Space Center to train the Apollo astronauts. It was used in conjunction with the Lunar Module Simulator. The simulated command module was patterned after the actual spacecraft. Although motion was not simulated physically, the sensations were provided by a visual system. The realism of the mission was maintained by simulating all aspects of the flight that the crew would encounter, including system sounds, failures, fire, life support, and food preparation. 3 simulation engineers conducted the training missions and had the capability to insert malfunctions to enhance crew training. This NASA video describes the operation of the Command Module Simulator in detail. Rendezvous Docking Simulator. Docking and undocking the Command Module with the Lunar Module was an essential part of the Apollo missions. Each mission required several such procedures. It was a difficult and somewhat risky maneuver, but it was crucial for the success of the moon missions. The simulator developed by NASA was suspended under a gantry at the Langley site as shown in this silent NASA video. It consisted of a command module which could be maneuvered by the trainee astronauts to dock with a lunar module. It provided the astronauts with a realistic training scenario on which they could practice the docking maneuver. The version shown in this video is for the Gemini missions. The Gemini simulator was modified later for use on Project Apollo. In this video from the Los Angeles Times, Sheila Thibault, a NASA aerospace engineer, describes her work on the Rendezvous simulator. In this video, she makes an extremely important point that the astronauts were unable to see the docking mechanisms by eye, but had to rely on a television camera. From a design point of view, this would appear to be somewhat of an engineering design error. Given that all the things that could go wrong, why introduce an additional element? In this final design, the safety of the astronauts was additionally reliant on a TV working correctly. It would have been far better for the astronauts only to rely on their eyesight rather than some extra equipment that could fail and leave them stranded in lunar orbit. Perhaps a mirror system could have been used. I was not party to the design considerations, so what they did may have been unavoidable for other reasons. Lunar lander simulation techniques. The actual lunar landing was one of the most complex aspects of the Apollo moon missions. It was something completely unknown in spaceflight at the time. Several simulation methods were employed to assist the astronauts in gaining experience of what could be involved in landing a spacecraft on the moon. The moon was so distant that mission control in Houston could offer little in the way of direct control due to the time delay of any control signals. An excellent animation of the moon landing procedure is shown in this video from Analytica Graphics Incorporated. NASA attempted to replicate the lunar landing using a machine designed to simulate lunar gravity here on Earth, but it was not entirely successful as a training vehicle. It was known as the Lunar Lander Research Vehicle, LLRV, or affectionately known as the Flying Bedstead. This vehicle almost killed Neil Armstrong on one occasion. Of the 5 such vehicles manufactured, 3 were completely destroyed in accidents. As a consequence, this dangerous method of astronaut training was abandoned in preference to more safe systems. Astronaut training was moved to a more controllable physical system and also to a safer ground-based simulator. NASA then constructed an enormous gantry at Langley in Virginia. The gantry comprised of a A-frame steel structure standing 240 feet high, 400 feet long, and 260 feet wide, quite an impressive sight. From this contraption, they could suspend a lunar module which allowed the astronauts to practice the final few feet of the moon landing approach. They even modeled a portion of the lunar surface at the base of the gantry to add to the realism. NASA claimed this of the gantry simulator. This training gave Neil Armstrong, Alan Shepard, and other Apollo astronauts the opportunity to study and safely overcome problems that could have occurred during the final 150-foot descent to the surface of the moon. The floor beneath the gantry was modeled to represent a cratered lunar surface. In the first part of this video, we see Armstrong and Aldrin practicing a landing in the lunar lander slung underneath the gantry. The remainder of this video looks at the Lunar Landing Research Vehicle LLRV, affectionately known to the astronauts as the Flying Bedstead, which we discussed earlier. This video shows a sequence of the landing approach at the Langley Simulator. Lunar Module Simulator. Several forms of lunar module simulators were used to simulate the view of the moon as it would appear during the landing approach. These included a simple rail tracking system in which a camera mounted on a rail rig would be tracked over a model of the lunar surface. When a complete lunar module became available, a more sophisticated simulator was created using computer screens outside the module window to project realistic views of the approaching lunar landscape. This new simulator employed a camera to track over an artificial moonscape. The astronauts inside the lunar module could practice all aspects of the moon landing in a realistic setting. A controller was able to create various faults from which the astronauts in the simulator would have to identify what was wrong and find solutions in which they could regain control. Lunar Landing Simulator Lola. This was an important simulator not only for training the astronauts in the art of landing on the moon, but also crucial to provide the footage that would be needed to pass off as being real. This video from Wendell Payne provides a somewhat rambling overview of the systems, but nonetheless provides a good summary of the techniques used to produce the fake Apollo videos. It was the Lola simulator that created those iconic lunar landing videos in which the simulated images dissolved into the real stage set with a flurry of an obscuring matte representing the blown sand. On the Apollo 14 landing video, the blown sand matte did not entirely obscure the simulated lunar landscape, and the image dissolves to the real stage sets shown the deceit as crater shadows did not resolve convincingly. Apollo Re-entry Simulator. The re-entry simulator of the Apollo capsule into the Earth's atmosphere is not such an easy task. It is easy to penetrate the atmosphere at high orbital speed and then burn up like a meteor. The problem is to enter slowly, but that would require a massive amount of fuel using ordinary rockets. The Earth's atmosphere presents a dense fluid medium as the Apollo capsule traveled at orbital velocities of almost 25,000 miles an hour encounters this obstacle. The Apollo capsule must hit the atmosphere at a precise angle and speed for a safe re-entry. If it hits too steeply or too fast, they risk being a big splash, which would involve a fiery end. If the impact is too shallow, the capsule may skip off the atmosphere and back into the void of space. The precise guidance of the Apollo capsule during the re-entry phase is therefore crucial. This NASA video from 1968 explains the problems. As the capsule begins to encounter the atmosphere at about 62 miles, the friction buildup causes a massive increase in temperature of up to 1700 C on the protective heat shield. Most metals and alloys would simply melt or be destroyed at such a high temperature. To solve this problem, the underside of the capsule is coated with a material known as an ablator. These materials can absorb and then radiate large amounts of heat for brief periods while they too are slowly destroyed. Ablators can be made out of a variety of materials, including phenolic resins, epoxy compounds, and silicone rubbers. You may well have silicone handles on your kitchen cookware and utensils. This NASA video from the 1960s also describes the re-entry simulator designed to train the astronauts on this most perilous part of their return journey home. You can see that the re-entry of the Apollo capsule is far from a trivial matter and not without considerable risk, as we saw with the tragic accident of the Space Shuttle Columbia in 2003. Lunar Module Procedure Simulator. This simulator accustomed the astronauts to several specific operations, which included navigation, guidance, and control procedures. About 40% of the astronauts' training time involved becoming proficient in the use of these 3 spacecraft navigation systems, 1 in the CM and 2 in the LM, and 4 guidance systems, 2 in the CM and 2 in the LM. NASA also produced a detailed manual on the lunar module versions from 10 to 14. An interesting article by Al Jackson, who worked on the procedure simulator during the Apollo period, describes some of the problems encountered in developing the simulator. Partial gravity simulators. Training the astronauts to become accustomed to the lesser gravity on the Moon involved a whole series of partial gravity simulators. Remember that the gravity on the Moon is only 1/6 of that on the Earth, so quite a significant reduction. Partial gravity simulators removed 5/6 of the astronauts' weight by some means of suspension support. One of the ways that NASA tackled the moon gravity problem for the astronauts' training involved the use of an inclined plane 9.5 degrees from the vertical. The astronaut is suspended in a harness in what looks like a very uncomfortable position. I often wondered why they used this form of awkward-looking simulation rather than a more obvious vertical position. There are several videos produced by NASA to illustrate how they simulated moon gravity for astronaut training. Particularly notice in these videos the extraordinary ability that the astronauts have to perform high jumps and even standing flips. None of these aerobatic maneuvers were ever seen in the Apollo moon videos. On the lunar surface, the best we saw was jumps of a maximum of 18 inches. The pro-NASA crowd may argue that the astronauts did not jump high on the moon for safety reasons. However, when you see some of the antics performed by these astronauts, it appears that safety was not a crucial consideration.